Okay, so today we're going to be focusing on the derivative of e to the x, the natural exponential function. We're going to start off by deriving it, which is kind of the point of this, using the definition of the derivative, meaning the difference quotient. So if we take f of x is equal to e of x, e to the x power, and we use the difference quotient, which means we're taking the limit as h approaches 0 of f of x plus h minus f of x all over h. And we use f of x is equal to e to the x power. What we actually have now is the limit as h approaches 0 of e to the x plus h power minus e to the x all over h. Now, because of properties of exponents, e to the x plus h power is equal to e to the x times e to the h power. Okay, that's just multiplying exponents with the same base. So if we rewrite this term as that over there, we would have the limit as h approaches 0 of e to the x times e to the h minus e to the x all over h. Now looking at the numerator, we have e to the x power in both of the terms, so we can actually factor that out. So we would take the limit as h approaches 0 of e to the x power times what's left, e to the h minus 1 all over h. Now since we're taking the limit of this as h approaches 0, e to the x is not affected by that. So we can actually remove e to the x out of this limit. Okay, so if we do that, we're left with e to the x times the limit as h approaches 0 of e to the h minus 1 all over h. Now, I could go into more details here, but suffice it to say, by definition, that equals 1. Okay, that's just the definition of what e is. That's just how it's created, really. So by definition, that this whole limit here is equal to 1. So what we're left with is just e to the x times 1, which is just e to the x, which is crazy to think about, that the derivative of e to the x is e to the x, and that's what we're saying right here. Okay, so the derivative of the natural exponential function, the derivative of e to the x, is e to the x. Okay, that's what you need to know. So, it gets more complicated than that, obviously. If we have the function y is equal to e to the tangent of x. Okay, now technically what we have to do is use the chain rule because we have the tangent of x inside the e to the x function. So we have to chain this. So y prime then would be equal to, well, the derivative of e to the x power or e to any power would be e to that power. But then you have to take the derivative of what's inside, and in this case what's inside is the tangent function. So the derivative of the tangent function is secant squared. So what we would actually have is e to the tangent of x times secant squared of x, probably more official writing it as secant squared x e to the tangent x. And that would be our derivative. Okay? It's a little bit more complicated when we have some other stuff, okay? Focusing on that first one up there, find dy dx if y is equal to e to the negative 4x sine of 5x. Okay, so now what you have to recognize is that you actually need to use the product rule here. You have e to the negative 4x as one function and sine of 5x as the other function. And within those functions, you have to chain rule. Okay, so e to the negative 4x. All right, well, product rule itself, if this is f and this is g, f prime times g plus f times g prime. I know I'm kind of interchanging my notations here, but you get the idea. So dy dx is equal to f prime, so the derivative of e to the negative 4x. Again, that would be e to the negative 4x times the derivative of negative 4x, which would be negative 4. Okay, that's that times g, which is just sine of 5x, okay, plus the original f function, e to the negative 4x, times the derivative of sine of 5x, which would be cosine of 5x, and then again chaining it, derivative of what's inside would be 5. So when we clean this all up, dy dx is equal to negative 4 sine of 5x e to the negative 4x plus 5 cosine of 5x e to the negative 4x. Now, you can probably get away leaving it like this, but we probably would like to factor the e to the negative 4x out of both terms there. So final form here would be e to the negative 4x times the quantity, and then also probably standard to write the positive term first rather than the negative term. So 5 cosine of 5x minus 4 sine of 5x. And that would be the derivative that we would have there. Okay. If we're finding a maximum or a minimum point, again, same thing. You take the derivative, except now you set it equal to 0. So if we have f of x is equal to x times e to the negative x power, again, that's a product rule. That's your f function. That's your g function. Okay, so f prime of x would equal the derivative of f, which is just 1, times e to the negative x, plus, you leave f alone, so x, and now times the derivative of e to the negative x, which would be e to the negative x times the derivative of the exponent, negative 1. Okay, so we got to clean that up first before we set it equal to 0. So you have e to the negative x plus, minus x e to the negative x. So that's what f prime of x is equal to. Again, notice how e to the negative x occurs in both terms. So when we're actually setting this equal to 0, we're going to take that e to the negative x out. You're going to be left with 1 minus x. And when we set that equal to 0, that's how we're going to find our critical numbers. And then we're going to take those critical numbers, plug them back into the original function. Okay, now, hopefully you understand you've got two terms here. And when you set e to the negative x equal to 0, well, it never equals 0 because it's an exponential function and it can't equal 0. So we don't get a critical number from that, but we are getting a critical number when we set 1 minus x equal to 0. Well, in that case, x is equal to 1. So that is our x coordinate of our absolute max or min. All we have to do now to figure out the y coordinate is to plug it back into the original. So f of 1 is equal to 1 times e to the negative first power. When we clean that up, that is just 1 over e. So the coordinates of the point here, it's actually a maximum, are 1 comma 1 over e. All right. And then finally, our last one, find an equation of the tangent line to the curve y equals e to the negative x sine x at the point pi 0. So again, take the derivative of the function, set it equal to 0, you don't need to set it equal to 0. Take the derivative of the function and plug in your x coordinate, in this case pi. That'll tell you the slope of your tangent line at that particular point. So again, y prime is going to equal, and wouldn't you know it, you have to use the product rule again. E to the negative x is your f function, sine of x is your g function. So derivative of e to the negative x function, e to the negative x times negative 1 times the sine function, because you leave it alone, okay, plus e to the negative x power, messed up my colors, e to the negative x power, derivative of sine, well, that's cosine, everybody knows that. All right, clean it up again. So you'd have negative e to the negative x sine of x plus e to the negative x cosine x. Okay. That's what y prime is equal to. So now again, we have to plug in pi into our equation to figure out the slope of the tangent line. So what we would actually have here is negative e to the negative pi power times sine of pi plus e to the negative pi power cosine of pi. Now, hopefully we remember our unit circles. Okay, sine of pi, pi is all the way on the left side. So the y-coordinate all the way on the left side is 0. So this whole term goes to 0 plus cosine of pi all the way on the left side is the x-coordinate all the way on the left, which is negative 1. So we actually have minus e to the negative pi power. So that's our slope. Our slope is equal to that. So if we rewrite this, m is equal to, if we simplify this, we'd have negative 1 over e to the pi power. Kind of looks crazy, okay, but that's what it is. It wants the equation of the tangent line. So using point slope form, we'd have y minus 0 is equal to our slope, negative 1 over e to the pi power times x minus pi. And you would most definitely leave it like that. In fact, the answer probably from the test would just not have that 0 there. So y is equal to negative 1 over e to the pi power times x minus pi as your final answer.